Hey, welcome back. We're going to look at problems 3 and 4 here in these worked examples. So what we're doing here is we're kind of, doing our first geometric proofs. So questions 3 and 4, okay, are showing us some statements about angles and then some statements about segments and asking us to name the property. Okay. Now, there's 3 properties that you need to know of. Okay. There is the reflexive property, which basically says that anything is equal to itself. Okay. There's the symmetric property, which says that when 2 things are equal, it doesn't matter which way you write it. You can write A equals B or B equals A. And then there's the transitive property. Transitive property, okay, which is a way of saying that multiple things are equal to each other, right? Or, I know in class I had done the silly example, Abe is the same age as Bob, Bob is the same age as Cam, Cam is the same age as Dave, Dave is the same age as Ed, right? And if I continue that pattern, right, what I can conclude then through that chain of events is that the very first person is going to be the same age as the very last person, right? Since they're the same ages as everybody in between them. Okay, so in the transitive property we say, okay, one thing is equal to a second thing, and then that second thing is equal to a third thing. Therefore, the first thing and the third thing are also equal to each other, right? Or the first and the last are equal to each other because they're both equal to the middle thing. Okay. So in a nutshell, the reflexive property, you can tell when this is happening because you're going to see the same thing on both sides of the equal sign. The symmetric property, you can tell it's happening because you're going to see only 2 different expressions, A and B. The transitive property has to involve 3 different expressions, A, B, and there's going to be a C expression. Okay, so there's only 1 expression in the reflexive property. You'll see 2 expressions in the symmetric property, and you're going to see 3 expressions whenever the transitive property is being used. Okay. All right, so let's look at question number 3. All right. So what do I see? I see angle RST is congruent to TSU. All right, so that's already 2 different expressions. And then I see angle TSU again. So I've already seen that one. It's the same thing as before. Is congruent to angle VWX. Okay. Therefore, RST, which happened to be the very first expression, is congruent to angle VWX. Right. And so how many different colors did I use? I used 3 different colors, right, for each of the 3 different angles. Right. So this statement involves 3 different angles or 3 different expressions. So I know that this is the transitive property, right? The first angle is congruent to the second, and the second is congruent to the third. So following that chain of events, the first angle must be congruent to the last angle or the third angle. So I can say that statement number 3 is an example of the transitive property. Okay, but specifically, I'm using the transitive property with angles. Okay, so transitive property of angle congruence. Okay, that is the kind of official name of the property, but as long as you can recognize that this is the transitive property, I think that's really good enough. Right, let's look at number 4. Okay, so this one's about segments. So we see there's a segment GH is congruent to JK. All right, so that's 2 different segments. Therefore, JK, all right, is congruent to angle GH. Right. Same 2 segments, just in a different order. Okay. So altogether, statement 4 involves only two different segments or two different expressions. And we know that if we see a statement with two expressions, that's probably, right, an example of the symmetric property. One thing is equal to a second thing, or vice versa. The second thing is equal to the first thing. We're just swapping the order, right? Only difference here is the order is being swapped. So this is an example of the symmetric property. Okay. But to be more specific, right, these are all segments. So I could say this is the symmetric property of segment congruence. Now I don't think I'm going to be super picky about, you know, whether you write angle congruence or segment congruence, just as long as you recognize that it's the transitive property or the symmetric property or possibly the reflexive property. All right, so we've got one more example coming up. This last example is going to be a full-blown proof, not a fill in the blank. We're doing all the steps on our own, so make sure you watch the last video.